Okay, so let's see. The Batmobile needs to stop from a speed of, he's going too fast. Its tires have a coefficient of 0.93 with the road. He goes into full reverse thrusters. What would be his acceleration if he stopped, and then what additional force would he need, presumably from the jet engines, right? Okay, so let's see. I'm trying to think about this. I think there's a Suvat problem, right? So let's figure that out first. Can't do anything without Suvat. If I don't have the acceleration, I can't solve this. I think we'll do Suvat, calculate the force of friction, and then set up an F equals ma type of thing. So let's see. Stops. So final velocity is 0. From a speed of 48.2, and then 50 meters, right? Okay, so my choice is to use v squared is u squared plus 2as. So a is going to be v squared minus u squared over 2s, right? So it's going to be 0 squared minus 48.2 squared divided by 2 times 50. Let's do that. 48.2. What am I doing? 48.2 squared divided by 100. Negative 23.2324. So the acceleration is negative 23.2324. And that's meters per second squared, right? Notice that it's negative, right? It's slowing down. We're going to use that same sign convention over here when we do our F equals ma, right? So here is, and the key here is you got to draw a good Batmobile. Giant honking engine there. Okay, so let's see. I don't know if that's a good Batmobile, but I think it's pretty good. Okay, so let's see. What would be his acceleration? Okay, so now the next thing I think is to figure out the force of friction. So he's using all the friction and the reverse thrusters, right? So there's going to be two forces backwards, right? There's going to be the unknown force, right? Right, and then there's also going to be the force of friction, which I imagine is bigger, but maybe it's not. Okay, so let's find the force of friction first. So that's going to be mu times m times g. That's going to be 0.93 times 1835 times 9.81. Okay, let's do that. 0.93 times 1835 times 9.81. Okay, here we go. That is 16,741.2. So this force of friction is 16,741.2 newtons. Okay? Comma there, right? That's our force of friction. And then here's our unknown force. Now, of course, we don't know it's negative. We're just going to let the cards fall as they may. Right? So now let's set up our friction thing here, right? This is a negative force because it's to the left, so I go negative 16,741.2, right? And then I'm going to say plus F equals, and then MA, right? I'm setting up F equals MA. And our M is 1835, and our acceleration is negative 23.2324. Negative 23.2324, yes it is, okay. And now we just do a little math here. So I'm going to go this guy plus this guy, right? So I'm going to go plus 1835 times negative 23.23224, okay. And I get that the force is equal to negative 25,890.2 newtons, in case you were wondering about that, right? Now we only have two sig figs. We really only have two sig figs, right? So I guess we would have to say this, right? This would be our, there you go.